Hi, guys. Okay, so let's look at the chapter 6 exercise problems on chemical composition. And we are using the Libre textbook, Introductory Chemistry by Tro. So the exercise problem 6.2.1 deals with finding the molar mass, the formula weight of a given compound. So how do you do this? So first of all, we need to understand that when no number is written here, that means that it's just one. But if something is written in the parentheses, that means this 2 applies to sulfur and this 2 applies to oxygen. Okay. Next, this 12 applies to hydrogen and this 12 applies to oxygen. And then this 2 applies only to hydrogen and this 4 only applies to oxygen. So this should be clear. Now, second thing is you should be able to recognize these symbols, recognize the symbols of the elements so that you can get their mass numbers from the periodic table. So the mass numbers are in the periodic table. So if you look at the mass number from the periodic table of potassium, so in this compound, we have 1 potassium, we have 1 aluminum, we have 2 sulfurs, and we have 4 times 2 or 2 times 4. Wait 1 second. 2 times 4 is equal to 8 oxygens. So that is one part. And then we have 12 times 2 hydrogens, and we have 12 times 1 oxygen. Okay, now what is their weight from the periodic table? So let's get that first. So times. So we are going to times that number, and whatever numbers we get, we are going to then add them. Okay, and then that's going to give us the molar mass. So let's get those numbers. So here's your periodic table. The same periodic table or similar is given to you in your handout also. So please use that periodic table on the exams. But right now, let's look at the potassium. So there are 2 numbers that are given. The bigger number, potassium, is K, right? So K stands for potassium, but it's kalium, more Latin name. Anyway, so 39.098. So in this case, it's okay to use 39. This is the mass number. Atomic number is 19, and atomic number means that's the number of protons. So we need the mass number of potassium, which is 39. Next, we need the mass number for aluminum. So here you go, look in the periodic table, look for the box in which there is aluminum. So in aluminum, again, there are 2 numbers. The bigger number is the mass number. So 26.982. You can round up to 27. So 27. 13 is the atomic number. That's not what you're going to use, the mass number only. So next is the sulfur. Sulfur is S. So 32.06. 32. It's okay to use. Okay. Then comes oxygen. Oxygen is 15.99. So you're going to use 16. Okay, and then comes hydrogen. Now hydrogen is 1.008. So it's okay to use for hydrogen as 1. Okay, so now let's going back to our this. So we are now going to put here, let me put it in a different color. So potassium 39, aluminum 27, sulfur 32. Okay, 2 times 4, 8 oxygens, 16. Okay, next is 12 times 1. Hydrogen is 1 and oxygen was 16. So now we're going to do the math. Okay, so you see that we did the math. So 1 times 39 is 39. 1 times 27 is 27. 2 times 32 is 64. 8 times 16 is 128. Okay. And that when you add it, it becomes 258. Similarly, there were 12, like 12 water molecules. So here we see 12 times 2, breaking it up into individually. So 12 times 2, 24 hydrogens, and 12 times 16, 192 oxygens. Now, when you're going to add these 258 plus 216, you're going to get the weight of 474. Okay, now when we talk about molar mass, we write it as grams per mole. Okay, 1 mole. But for like, if you're just looking at is the formula weight or the molecular weight, then it's okay to use it at 474 atomic mass units, or even the formula weight. Okay, because it's a molecule, it's a big, compound. So this is a formula weight. Okay, now another thing, formula weight, molecular weight. I mean, everything is a molecule, that's one thing. But now we have differentiated. Formula weight, we apply to the ionic compounds. Molecular weight, we apply to the non-ionic compounds. But older books are sometimes also using molecular weight. So that's why, it's molecular weight is common. So formula weight is more for ionic compounds. So let me put this here. For ionic compounds. Now, what are ionic compounds? Ionic compounds are those that are made up of metals, non-metals, and polyatomic ions. Okay, so that's one piece. Next is how many moles are there in 100 grams of aluminum. So here we are given 100 grams of aluminum. So always write down the given, whatever is given to you, times. You're going to put it with that conversion factor in which the units that you want go on the top, the want units on the top, and the units that you want to, convert from. So the units that you want to cancel out or remove, let's say remove. The removed units are at the bottom. So remove unit is the one that you're converting from. So convert from. So from goes on the bottom. Okay. And this is the unit that you want to convert to. So given units and the removing units cancel out. That is why they are placed diagonally. Okay, these units are the same. So this is the units that the unit that you want are on the top, and this top also means numerator. Okay, and the bottom is the denominator. So that cancels out. So anyways, so here we would need something. And that is because we need to convert to moles, and we are given grams, and we need the molar mass. So again, we are going to look at the periodic table, and we're going to get the molar mass of aluminum. So we know it from aluminum, from our previous example, was 27. We already looked in the periodic table. So 27 grams per mole. Okay, now what is the meaning of this? This means 27 grams is equal to 1 mole, or 1 mole over, because we need to convert to moles. So moles is on the top. This is the conversion factor, over 27 grams is at the bottom. Okay, and this is of aluminum. So always write down of what, element or what species. And you're going to write down your given. The given is 100.0 grams of aluminum. Okay, times 1 mole over 27 grams. So when you set it up like this, what happens is that the grams and grams of aluminum cancel out, and you're just left with the moles. So now just simple doing the math is 100.0 times 1 divided by 27. So what do you get here? 100 divided by 27. And this is 3.70 moles of aluminum. 3.0037. So 3.2 decimal places is fine. Okay. But if you really want to look into the significant figures, then we can also look at it this way. We are looking at 4 significant figures here. 1, 2, 3, 4. So 4 significant figures. So according to the answer we get is 3.7. Let me put it here. 3.7037. So this can be made into answer 3.7. 3 becomes 4, right? You're dropping off. So that's the answer. Okay, but in the book, if it is 3.706, then most likely then they used the like the more decimal spaces for the periodic table, from the periodic table, the mass numbers. They did not convert it, they did not change it, they did not round it up there. So slight discrepancy in the last digit, it's okay. Okay, now here, what mass means grams. So you're talking about silver. Okay, so same thing. Now we are going to write down. Now you understand how the setup is here. I wish I had more space, but let me see if I can move this a little bit down here. Okay. All right, so this is 27. And here, just cleaning up a little bit. So this one is, just make it small, so this way. Okay, now let's look at the scenario with silver. So silver in the periodic table, look at the mass for the silver in periodic table. So silver is Ag, and we see that Ag is right here. So it is 107.87, but you can make it 108. Okay, so silver is, the molar mass of silver is, the molar mass of silver is 108. So molar mass of silver is 108 grams per mole. What is the meaning of this? This means 1 mole over 108 grams, or 108 grams over 1 mole. So this is for the silver. This is the two conversion factors. So which one are we going to do? We are converting moles to grams here. So you're going to write down the moles, 0.552 moles of silver, right? Times that conversion factor that cancels out the moles. So that means the moles are going to be in the denominator. So 1 mole of silver, and then because you're converting to the grams, so this 108 grams, the unit that you want stays on the top. And always write down the species. Okay, so it's silver in this case. So the moles of silver and the moles of silver cancel out. Now moles, M-O-L-E-S, and M-O-L is the same thing. M-O-L is just short form or the unit for moles, so it means the same. Okay, when it's written. So now what do you have here? You have 0.552 times 108. So let's see, what do we get here? 0.552 times 108, and the answer is equal to 59.61. So 59.61 grams, but the book is saying 59.5, which is okay, because I uses the rounded up number for the silver. So had I used the exact number, I would have gotten the exact same answer. So it's up to you, but normally we use the rounded up masses from the periodic table. Okay, next, here is the species that is given to you: carbon, 3 chlorines and 1 fluorine, CCl3F. Calculate the formula weight or the molecular mass. So here we are going to look at how many carbons there are. So we have 1 carbon, and we have 3 chlorines, and we have 1 fluorine. Okay, so we are calculating the molar mass. So 1 carbon, 3 chlorines, and 1 fluorine. And look at the individual molecular atomic weights. So carbon, chlorine, and fluorine. So once again, carbon is 12.01 for carbon. Chlorine is 35.45. So normally we use 35, right? And fluorine is 18.998. So we make it 19. So here's, so here, commonly used, I'm doing that, 12 grams. Chlorine is 35. Right, and it's okay if you want to use 35.45. Fluorine is 18 point something, 18.99, so it's 19, sorry. So it's 19. Okay, so commonly used are these numbers, rounding up and or leaving as it is. Okay, so this is 12 and 35. Let's see, 35 times 3. 35 times 3 is equal to 105. 35 times 3 is 105. And then the other one is 19. Okay, so add all of this. So what do you get here? 105 plus 12 plus 19. And the answer is 136. Okay, 136 grams per mole. Okay, next is for SiN4, Si3N4. What does this mean? There are 3 silicas and there are 4 nitrogens. Okay, there are 4 nitrogens. And then look at the weight of silica and look at the weight of nitrogen. So here we see the silicon is 28.085. So 28, it's okay to use. And the other one is nitrogen. Nitrogen is 14.007. So it's okay to use 14. So 14 and 28. 14 here and 28 here. So let's do this here. 28 times 3 and so 28 times 3 is equal to 84. And 14 times 4, 14 times 4 is equal to 56. Okay, so 56 plus 84 is equal to 140 grams per mole. Okay, all right. Next is, okay, our next question is taking 7.50 moles of calcium oxide and converting that to the mass, which is in grams. Okay, so here we are looking at calcium oxide. So we need to get the molar mass of calcium oxide. And calcium oxide, calcium, there is only one calcium and there is one oxygen. So calcium and oxygen. Once again, let's look at the periodic table and we will see calcium, Ca. So calcium is 40.078. Now your book is using the exact numbers, the decimals. That's why there's a slight change in the answers, like, you know, decimal points, but that's fine. So here we are looking at calcium 40.078. So, sorry, calcium is 40 and oxygen is 16. So we have 40 plus 16 and that is 56 grams per mole. Okay, now we are given 7.50, right, moles of calcium oxide, right, times that conversion factor. That gives you the grams of calcium oxide on the top and the moles of calcium oxide at the bottom, because you want to cancel out the moles of calcium oxide, right, and convert that to grams. So from here, we see that 1 mole of calcium oxide, the weight is 56 grams. So now when you set the problem this way, you will see that the moles of calcium oxide and the moles of calcium oxide cancel out, and you're only left with the units of grams. So now we are going to multiply 56. So 56 times 7.50 and over 1, you know, so what do you get here? So 56 times 7.50 over 1 is equal to 420. Okay, and this 420 grams of calcium oxide. That's the answer. So I have the answers. Like I said, your book is using more exact. So I'm going to put it here. The book is using the book, or rather the book is not rounding up or rounding numbers up or down, means as is rounding numbers. So therefore, slight variation in answers. Variation in answers. Okay, but that doesn't mean that the answer is wrong. The method is correct. Okay, so these are right answers. All right, next is, these are the right answers. 420. Okay, so I have the answers written just so I could show. Okay, next is, we are going to look at for nitrogen. So again, look in this thing here. So the book is using the exact number as you see in the periodic table for nitrogen, but I'm rounding up. So here nitrogen is 14, or rounding in general, 14.007. So what do you see here? So nitrogen, there are two nitrogens Each is weighing 14 grams. So this becomes 28 grams per mole. Okay, so write down, we need to find the mass. So we are given 7.50 moles of nitrogen, okay, times 1 mole of nitrogen, because this is going to be cancelled out, weighs 28 grams. We want the units of units. We want the units of grams. So therefore, we are subtracting the moles. So cancelling out the moles of nitrogen. So what do you get here? 7.50. So here we have 7.50 times, what am I having here? 7.50 times 28. And you have 210. So this is 210 grams of nitrogen. Okay, that's the answer. Okay, next is how many formula units? How many formula units? So you are given the, basically formula units are in this case, they are using the formula units as like the number of atoms, that make up a molecule. And so just give me 1 second here. Okay, so when we talk about formula units, in this case, we are looking at how many molecules, because this is a compound, and obviously these are molecules, 2 or more different types of atoms. So you are given, so when we talk about formula units, we are talking about how many molecules. So let me write this down. A better phrase for this is how many molecules are there? How many molecules are present in 25.0 grams of CaCl2. Okay, so this is the other way of writing this. Now here, the thing is that we know that 1 mole of any substance, so 1 mole of calcium chloride contains 6.022 into 10 to the power 23 molecules. Okay, so molecules of calcium chloride, and then that is equal to the molar mass of calcium chloride. So what is the molar mass of calcium chloride? One calcium and 2 chlorines. So 1 calcium is, we had this here, 1 calcium is 40 grams, okay, and 2 chlorines is 35 grams. So a total of 40, 35 times 2 is 70, and then 40. So this becomes 110 grams per mole. And that is the molar mass for calcium chloride. Okay, so this is equal to 110 grams of calcium chloride. So you see here that 1 mole of calcium chloride is equal to 110 grams, and then this contains 110 grams of calcium chloride contains the Avogadro's number of particles. In this case, we are looking at the molecules. So now let's just set up the problem. So, you know, you can do a direct conversion. Your book is saying you first convert to moles and then to the number of molecules, but you can do it directly also. It's not a big deal. So here you were going to just put it, let's do this here, 25 grams of calcium chloride, okay, calcium chloride. So the book is saying you first convert to moles and then, but like I'm going to do it direct, times that conversion factor in which you are given the number of molecules on the top. So in this case, there is going to be the Avogadro's number of molecules on the top are present in how many? 110 grams of calcium chloride, and that is the molar mass of calcium chloride. The whole purpose of molar mass is, you know, to basically quantify how many atoms or molecules are we working with. So you just set up the problem like this. So let's do it. 25 grams, 25 point, what do they, very exact, 24.0 grams of calcium chloride, multiply by Avogadro's number, 6.022 into 10 to the power 23 molecules. Okay, because the question is asking how many molecules. That is why you bring the Avogadro's number. Is present in 110 grams of calcium chloride. Okay, and this is molecules of calcium chloride. So this way, if you see, you have gotten rid of the grams of calcium chloride and you're just left with the molecules of calcium chloride. The rest is the math. Now, those students, you can simply put this problem on a scientific calculator and you'll be okay. You can get the answer from there. Otherwise, you can do it manually also. This means 25 times 6.022. Okay, divide that by 110. So let's do that first. And this whole thing is times 10 to the power 23. So let's see what we get here. Okay, so 25 times 6.022, divide that by 110, and that is 1.36. 1.36 into 10 to the power 23 molecules. So that is the correct answer of calcium chloride. Okay, so we see in this case, this is the answer is 1.36 10 to the power 23 molecules. Let me highlight all the answers here. 210 nitrogen. And then here we have 420 grams of calcium oxide. We have 140 grams, 136 grams per mole. This one is 59.61. And this one is 3704 moles. And this, the first one is 4. So all the answers are highlighted now in yellow. Okay. So, that's the answer. Okay, next is you are given, the next question is you are given the moles of sodium sulfate. And now you're saying find how many moles of sodium atoms. So there's a language. If the question is asking how many moles of, then you don't do. But if they say how many molecules, in that case, you're going to bring the Avogadro's number. Okay, Avogadro's number. 6.022 10 to the power 23. Okay, now let's do this one. Here we see you're given the moles and so it's a direct mole to mole conversion. So what is the meaning of this? First of all, 1 mole of Na2SO4. Okay, sodium sulfate. 1 mole of sodium sulfate. It has 1 mole of sodium sulfate has 2 moles of sodium, 1 mole of sulfur, and 4 moles of oxygen. Okay, so you can set up the conversion factors from here. 1 mole of sodium sulfate, Na2SO4, contains, so depends which one are we looking at, 2 moles of sodium. 2 moles of sodium atoms. Okay, 2 moles of sodium atoms. Next is 1 mole of sodium sulfate, Na2SO4. Okay, contains 1 mole of sulfur, and then 1 mole of sodium sulfate, Na2SO4, contains 4 moles of oxygen. Okay, now here, let me just make this small. We can also flip it, right? Depending, we can flip these. So what we can flip in the sense that you can flip this. These can be flipped, all right? So this can come here and this can come here. This number can come here. So sorry, I forgot to put atoms. Okay, so here we see this goes like this. This can come here and this can come here. So these can be flipped, right? Conversion factors. All right, so now let's do. Our focus here is on each one of them, but we are going to take that conversion factor in which the moles of oxygen are on the top. Okay, so moles of oxygen are on the top, but the moles of the total moles, 1 mole is there. So we are given here 6 point. So let's put this here. So let's look at the relationship of first sodium atoms. Okay, so we are given 6 6.75 moles of Na2SO4. Okay, times, we need to find how many sodium atoms are there. So 2 moles of sodium atoms are present in 1 mole of Na2SO4. Okay, next is 6.75 moles of sodium sulfate, Na2SO4. Okay, times how many sulfur atoms? There are 1 mole of sulfur atoms. Okay, 1 mole of sulfur atom over 1 mole of Na2SO4. Next is 6.75 moles of Na2SO4 times oxygens. So there are 4 mole of oxygen atoms over 1 mole of Na2SO4. Okay, so here we see that the moles of sodium sulfate and the moles of sodium sulfate cancel out. Moles of sodium sulfate and sodium sulfate cancel out in all of them, and all you're left with is just the moles of sodium atoms, moles of sulfur atoms, and the moles of oxygen atoms. So these are the conversion factors. Okay, the conversion factors, we use the conversion factors to bring this about. All right, let's do the math now. Okay, so when you do the math, you get 13.5 moles of sodium atoms, 6.75 moles of sulfur atoms, and 27 moles of oxygen atoms. So these are atoms. All right, so these are the, sorry, this is, I should have written this here, sodium atoms. This is sulfur atoms. And here we are looking at the oxygen atoms. So you set up the problem like this, okay? So it's very important that, it's very important that we get the conversion factors right, okay? All right, next is the how many molecules. You are given 16.02 moles of butane, C4H10. How many carbon atoms are in 16.02 moles of butane? So here, parts to whole problems. And carbon atoms, how many carbon atoms? So, and how many molecules? So how many molecules? Every time there's a question where it say how many molecules, means number, like counting number. So here we are somewhere, this is a clue that the Avogadro's number is going to be used. Avogadro's number to be used. So that is a clue. So that's one piece. Next is how many carbon atoms. So that is it. The number of carbon atoms are in. So it's small, like a small part of a big whole. Okay, so that type of problem. All right, let's do this. So first is, we know that 1 mole of any substance. So here it is 1 mole of C4H10 is going to contain 6.022 into 10 to the power 23 molecules of C4H10. Okay, so that's one thing. Next is 1 mole contain 1 mole. So this, based on this, you can create the conversion factors. Okay. Next thing is how many carbon atoms are in 16.02 moles. So for this one, we know that 1 mole of C4H10 contains 4 moles of carbon atoms. Okay, so these two things, these two are like kind of known equalities, right? This is something that is known. So let's do one part here. So here we see you're given 16.02 moles of C4H10 times, because we need to find how many molecules are there. So we know that in 1 mole of C4H10, there are 6.022 into 10 to the power 23 molecules. of C4H10. Okay, so here you see that the moles of C4H10 and the moles of C4H10 cancel out, and you're just left with the unit of molecules, which is what you need to find. The rest is just math. 16.02 times 6.022 into 10 to the power 23, and that is molecules. So let's do the math. So here we see 16.02 times 6.022, and the number you get is 96. The number you're getting here is 96.472. Okay, now if you really look at it, 1, 2, 3, 4, 1, 2, 3, 4, 4 significant figure. So the answer should also have 4 significant figure. So we are going to keep 1, 2, 2, 3, 4, and we can drop off 2. Okay, but remember, you can drop 2 and 2, so the rest of it remains as is, because 7 is less than, 7 is more than 5. The leftover is 7. So sorry, the 2 is less than 7. So the 2 is less than 5, sorry. So 7 remains as is. Okay, so we will, another thing that we will do here is 96.47 we need, but we're going to move the decimal one place to the left and into 10 to the power 23. So 23 becomes plus 1. So one place, we moved one place to left, and that one place to left is that one number. So now what is the answer? The answer is 9.647, okay, into 10 to the power 24. So if you move to the right, it's reduced. The exponent 23 gets reduced. But if you move to the left, it's added. It gets added by whatever digits or whatever places you're moving the decimal to. Okay, so that's one thing. Next is, so that answer matches with the given answer, and that's one piece. Next is, so this is always write down what it is. So these are the molecules of C4H10. Okay, next is, you are given 16.02 moles. How many carbon atoms are there? So the next step is 16.02 moles of C4H10 times 1 mole, no, sorry, how many? 4 moles. 4 moles of carbon atoms. 4 moles of carbon atoms are present in 1 mole of C4H10 molecules. Remember, atoms are a part of molecules. So here you will see that the moles of C4H10 and the moles of C4H10 cancel out. You see, it's easy. So next is, you're going to multiply, do the math. You're going to multiply 16.02 times 4, and that gives you 64 point, oh wait, 1 second. They are actually, okay. We will have to do more, because the question is asking how many carbon atoms are there, I think. How many carbon atoms? Yeah, how many carbon atoms? So we are going to do one thing, one step more, and that is, we are going to we can convert it into moles. So we know that 1 mole of any, carbon atoms are 6.022 into 10 to the power 23. Okay, carbon atoms. Okay, so here we see that the moles of carbon atoms and the moles of carbon atoms cancel out, and you are left with, and you're just left with the atoms of carbon. So let's do this again. So 16.02 times 4 times 6.022 and that gives you 385. So here it is. This gives you 3. So let me do this in red. This gives you 385.88 into 10 to the power 23, right? But you're going to move the decimal place 1, 2, 2 places to the right. So what does this become? 2 places to the right. And here you moved 2 places to the left. So what do you get here? You're going to get, the answer is 3.85 and 4 places, 3.85. Then it becomes 9 into 10 to the power 25 carbon atoms. Okay. All right. So that gives you the answer. Okay. All right. So that's the answer. And this one also is the answer. And I'm sorry, this is looking very cluttered, but you know, that's what it is. So anyways, calculate the percentage composition in H2SO4. Let me see if it is still, maybe it's still manageable. If students want to do it, then I think it's reasonable. They will at least apply themselves. All right, now let's look at it here. Percentage composition of sulfuric acid. So in this case, you are given, we need to, in sulfuric acid for each. So what is the percentage for hydrogen? Hydrogen percentage is what? What percent is sulfur, and what percent is oxygen? Okay, so percentage of each of them we are going to calculate. So you are given the 196 grams of H2SO4 sulfuric acid, and you are also given 64 grams of oxygen, and you're given 4 grams of hydrogen. So what will you do? You are going to just, so since oxygen, hydrogen, 196 grams of sulfuric acid. Okay, so only 2 entities are given. So sulfur is not given. So we can find that one out. Okay, so you see here, one thing very important, that 64, the total, this is the total, 196.0 grams is the total amount of sulfuric acid, the total sample, right, of H2SO4. Okay, out of this, we see that 64 grams is oxygen, and we see that 4 grams is hydrogen. So this becomes 68 grams is the others. Okay, to find, so this is the, so let me put this properly. So sorry, 64 grams of hydrogen. Okay, so here 196. So we need to find how much is the sulfur first of all, because that's not given to us. How much or how many grams is sulfur? Okay, in 196 gram sample. So this is what we need to find first, because only then we can get a percentage for sulfur. So what do? 196 grams, that's the total, minus the weight of the weight of 64.0, that's the grams for oxygen, plus 4 grams, 4.0 grams for hydrogen, okay, is equal to the grams of, or the weight of grams of sulfur. Okay, now 196, so this becomes 196, 64, so 64 plus 68. So basically 196 minus 68, and that is 128. So 196 minus 68 grams is equal to 128. 128 grams is sulfur in that sample. And now you just do individually. So the percentage of hydrogen is 4.0 grams. Hydrogen is present in the total. Total is 196 grams of H2SO4 times 100%. Okay, next is the percentage of sulfur, and that is 128 grams of sulfur. Okay, 128 grams of sulfur over the total 196 grams of H2SO4. Okay, times 100%. 100%. Okay, and then comes the percentage of oxygen, and that is 64.0 grams oxygen over 196 grams of H2SO4 times 100%. Okay, so what do you get here? You get 4 divided by 196 times 100, and that gives you 2.04% is the hydrogen. The next is 128 divided by 196 times 100, and that gives you 65.30% is the sulfur, and then oxygen is 64.0 divided by 196 times 100%, and that gives you 32.65% is the oxygen. Okay, so basically this is a parts to whole. You just follow this times 100%. So that's the formula. Okay, and those are the answers. The answers are this, this, and this. All right. Okay, so next is barium fluoride. Now, this is the last question here. Barium fluoride, find the percentage composition. Now, in this case, they did not give you the grams of the sample. They just said, find the percentage composition of barium fluoride. So in this case, first of all, you should know how to write a formula of barium fluoride. Barium is group 2A. How do I know? You need to check since you're learning also. So here is the barium. Barium in group 2A, right? 2A and barium, BA, barium. And this is present in the group 2A, so it will have +2 charge. And its weight is 137. This also we need. So first of all, it's very important you learn how to write the formula. So this will have a +2 charge. So it is going to form barium +2. Next is the fluoride. Fluoride is coming from fluorine. Fluorine is in 7A. The charge is -1. So this is how you will write this. So now you make the correct formula first of all. So BA +2 and F is -1. So when you crisscross, this comes here and this number comes here. So what do you get here? You get BA F2. So there are 2 fluorines and 1 barium. Okay, so first find the molar mass, and in that we are going to look at the of BaF2. So let's look at the mass of barium. Barium is 137.33, so it's okay to use 137, and fluorine is 18.99, so it's okay to use 19. So let's do this. 137 plus 2 times fluorine is 2 times 19. So that's for the coming from the barium, and that's coming from 19 is coming from fluorine. So what do you get here? So 137, 2 times 19 is equal to 38, and 38 plus 137, and that gives you 175. 175 grams per mole. So that is the molar mass for barium fluoride. The rest of it is you're just going to put 137 grams of barium is present in 175 grams of barium fluoride, BaF2, times 100%. Okay, and then the other one is since it's 2, so it was 38 grams of, so this becomes 38. This is 38. So 38 grams of fluorine over 175 grams of BaF2 times 100%. Okay, so what do you get here? So let's do this. 137 divided by 175 times 100, and that gives you 78.28, 78.28% barium. Okay, and then the other one is 38 divided by 175 times 100%, and that gives you 21.71, 21.71. So 21.71%. Okay, and that is the fluorine. And then this one was 78, I forgot now, 32% barium. Okay, all right. So this is how you calculate for the percentage composition in, you know, where the numbers, the amount of the substance is known. So in that case, you're going to just use the molar mass and then find it there. So this finishes all the exercise problems here, and we are going to just now look at the next problems. All right. Thank you for watching. Bye-bye.